gain knowledge about electrical services, especially regarding wiring, several avenues are available for self-directed learning. Firstly, consider books. The Lineman's and Cableman's Handbook, 12th edition, by Thomas M. Shoemaker, offers comprehensive coverage of electrical wiring, fiber optics, and cable television systems. It is a valuable resource for understanding the broad scope of electrical work. Secondly, the Residential Construction Wiring Manual, 6th edition, by Harry W. Beeler, focuses specifically on residential wiring. It covers installation techniques, inspection procedures, and troubleshooting common issues in residential electrical systems. Thirdly, the National Electrical Code, known as the NEC, is the official standard governing electrical wiring in the United States. It provides detailed specifications and safety requirements that must be followed for all electrical installations. This is not a book to read cover to cover, but a reference to consult for specific rules and regulations. Fourthly, the Electrician's Pocket Manual, 6th edition, by Rex Miller, serves as a quick reference guide for electrical wiring. It includes typical formulas, tables, and diagrams that electricians commonly use in the field. Fifthly, Motor Control Fundamentals for Industrial Maintenance, 2nd edition, by William E. Simon, covers electrical motors, wiring, and motor control circuits. This is particularly useful if interest lies in industrial applications. Now let us consider online resources. The Electrical Connection website at https://www.electricalconnection.org/ provides a wealth of resources on electrical wiring, including tutorials, articles, and discussion forums. It's a great place to find answers to specific questions and engage with other professionals. The National Electrical Contractors Association, or NECA, website at https://www.necanet.org/ offers industry standard information on electrical wiring, safety practices, and code compliance. NECA is a leading organization for electrical contractors, and their resources are highly reputable. The International Brotherhood of Electrical Workers, or IBU, website at https://www.ibu.org/ provides educational materials and resources for electrical workers, including detailed wiring information. The IBU is a labor union representing electrical workers, and they offer extensive training programs. Engineers Edge Electrical Engineering Calculator, found at https://www.engineersedge.com/electrical engineering/electrical engineering calculators/ offers various calculators and tools for electrical wiring design and analysis. These tools can help perform calculations related to voltage drop, current carrying capacity, and other important parameters. Home Depot Electrical Wiring Guide, accessible at https://www.homedepot.com/e/app/electrical wiring guide/Nanbase 683,603 Benin 5395 99774 provides a comprehensive guide to residential electrical wiring, including videos, how-to articles, and safety tips. It is a good starting point for learning the basics of residential wiring. Beyond books and websites, there are other resources available. YouTube channels dedicated to electrical wiring can be a valuable source of information. Search for channels such as Electro Boom, The Handyman, and This Old House. These channels often provide practical demonstrations and explanations of wiring techniques. Online forums and communities dedicated to electrical wiring, such as Electrical Forum and DIY Chatroom, can provide a place to ask questions, share experiences, and learn from others. Engaging with experienced electricians in these forums can be very beneficial. Visiting a local electrical supply store offers the opportunity to talk to staff about wiring materials and best practices. They can provide advice on selecting the right types of wire, connectors, and other components for specific applications. Furthermore, consider attending workshops or classes offered by local community colleges or vocational schools on electrical wiring. These courses can provide hands-on training and a more structured learning environment. When studying electrical wiring, it is essential to understand the different types of wires and their applications. Common types of wires include non-metallic, or NM cable, which is commonly used for residential wiring. It consists of 2 or 3 insulated conductors and a ground wire wrapped in a plastic sheath. THHN or THWN wire are single conductor wires used in conduit. THHN stands for thermoplastic high heat resistant nylon, while THWN stands for thermoplastic heat and water resistant nylon. These wires are commonly used in commercial and industrial applications. Underground feeder, or UF cable, is designed for direct burial in the ground. It is typically used for outdoor lighting, pumps, and other underground applications. Electrical metallic tubing, or IMT, is a type of metal conduit used to protect wires. It is commonly used in commercial and industrial buildings. Rigid metal conduit, or RMC, is a heavier type of metal conduit used for more demanding applications. It is often used in areas where wires are subject to physical damage. When working with electrical wiring, it is crucial to follow all safety precautions. Always turn off the power before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical wiring in wet conditions. If ever unsure about any aspect of electrical wiring, consult with a qualified electrician. Electrical work can be dangerous if not done properly. Understanding electrical circuits is fundamental to understanding electrical wiring. An electrical circuit is a closed loop that allows electrical current to flow from a source to a load and back. The source of electrical current is typically a power supply, such as a battery or an electrical outlet. The load is the device that uses the electrical current, such as a light bulb or a motor. Wires act as conductors, providing a path for the current to flow. There are 2 main types of circuits: series circuits and parallel circuits. In a series circuit, the components are connected in a single path. The current flows through each component in turn. If one component fails, the entire circuit is broken and no current flows. In a parallel circuit, the components are connected in multiple paths. The current can flow through each component independently. If one component fails, the other components will continue to function. Electrical wiring diagrams are used to represent electrical circuits. These diagrams use symbols to represent the different components in the circuit. Understanding these symbols is essential for interpreting wiring diagrams. Resistors are components that resist the flow of electrical current. The resistance of a resistor is measured in ohms. According to Ohm's law, the voltage measured in volts across a resistor is equal to the current measured in amps flowing through it multiplied by the resistance measured in ohms. This is expressed as voltage equals current times resistance, or volts equals amps times ohms. This law is fundamental to understanding electrical circuits. Capacitors are components that store electrical energy. The capacitance of a capacitor is measured in farads. Inductors are components that store energy in a magnetic field. The inductance of an inductor is measured in henries. Diodes are components that allow current to flow in only one direction. Transistors are components that can amplify or switch electrical signals. Integrated circuits, or ICs, are complex circuits that are fabricated on a single semiconductor chip. They can contain millions or even billions of transistors and other components. Understanding the function of these components is essential for troubleshooting electrical circuits. When working with electrical wiring, it is important to understand the different types of electrical outlets. Standard electrical outlets in the United States provide 120 volts. These outlets have 2 slots, a narrow slot for the hot wire and a wide slot for the neutral wire. There is also a round hole for the ground wire. Ground fault circuit interrupters, or GFCIs, are special types of outlets that are designed to protect people from electrical shock. GFCIs constantly monitor the current flowing through the hot and neutral wires. If there is a difference in current, it indicates that some of the current is leaking to ground. The GFCI will quickly trip, cutting off the power to the outlet. GFCIs are required in bathrooms, kitchens, and other areas where there is a risk of electrical shock. 240 volts outlets are used for appliances that require more power, such as electric stoves, dryers, and air conditioners. These outlets have a different configuration than 120 volts outlets. They typically have two hot wires, a neutral wire, and a ground wire. When wiring an electrical outlet, it is important to connect the wires correctly. The hot wire should be connected to the brass screw, the neutral wire should be connected to the silver screw, and the ground wire should be connected to the green screw. If the wires are not connected correctly, the outlet will not function properly and could be dangerous. Electrical panels, also known as breaker boxes, are the central distribution point for electricity in a building. The electrical panel contains circuit breakers that protect the electrical circuits from overload. Each circuit breaker is designed to trip if the current in the circuit exceeds a certain level. This prevents the wires from overheating and causing a fire. When installing a new circuit, it is important to select the correct size circuit breaker. The size of the circuit breaker should be based on the amount of current that the circuit will be expected to carry. The National Electrical Code provides guidelines for selecting the correct size circuit breaker for different types of circuits. When working with electrical panels, it is important to follow all safety precautions. Always turn off the main power breaker before working on the panel. Use insulated tools and wear appropriate personal protective equipment. Never work on electrical panels in wet conditions. If unsure about any aspect of working on an electrical panel, consult with a qualified electrician. Electrical codes and standards are essential for ensuring the safety of electrical installations. The National Electrical Code, or NEC, is the primary electrical code used in the United States. The NEC is updated every 3 years by the National Fire Protection Association, or NFPA. The NEC provides detailed requirements for electrical wiring, equipment, and installations. State and local governments may adopt the NEC or develop their own electrical codes. It is important to be familiar with the electrical codes that are in effect in your area. Underwriters Laboratories, or UL, is an independent organization that tests and certifies electrical products. UL-listed products have been tested and found to meet certain safety standards. When purchasing electrical equipment, look for the UL listing mark. The American National Standards Institute, or ANSI, is an organization that develops and publishes voluntary consensus standards for a wide range of products and industries. ANSI standards are often referenced in electrical codes and regulations. Learning about electrical wiring can be a challenging but rewarding experience. By utilizing the resources mentioned, including books, websites, YouTube channels, forums, and local electrical suppliers, you can gain a solid foundation in electrical wiring principles and practices. Always prioritize safety and consult with a qualified electrician when working with electricity. Remember the importance of understanding the types of wires, electrical circuits, outlets, panels, and relevant codes and standards. Firstly, understanding the ampacity of wires is critical. Ampacity refers to the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. The National Electrical Code, specifically Table 310.15b16, provides ampacity ratings for various conductors based on their size, insulation type, and installation conditions. Secondly, conductor size is directly related to ampacity. Larger conductors have a greater cross-sectional area, allowing them to carry more current safely. Conductor size is typically expressed in American wire gauge or AWG. Smaller AWG numbers indicate larger conductors. Thirdly, insulation type affects ampacity. Different insulation materials have different temperature ratings. Common insulation types include THHN, THWN, and XHHW. Each insulation type has a maximum operating temperature, which affects its ampacity. Fourthly, installation conditions impact ampacity. The way a conductor is installed, such as in conduit, free air, or buried underground, affects its ability to dissipate heat. The NEC provides adjustment factors for ampacity based on the number of conductors in a raceway or cable. Fifthly, voltage drop is a critical consideration in electrical wiring. Voltage drop refers to the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Sixthly, grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, causing the circuit breaker to trip and energize the circuit. The NEC requires all electrical systems to be properly grounded. Seventhly, bonding is closely related to grounding. Bonding connects all metal parts of an electrical system together to create a low impedance path for fault current. This helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. Eighthly, overcurrent protection is vital for preventing electrical fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current if it exceeds a safe level. The NEC requires all electrical circuits to be protected by overcurrent protection devices. Ninthly, arc fault circuit interrupters, or AFCIs, are designed to detect arc faults, which are a common cause of electrical fires. AFCIs can detect arc faults that standard circuit breakers may miss. The NEC requires AFCIs in many residential circuits. Tenthly, surge protection is important for protecting electronic equipment from voltage surges. Voltage surges can be caused by lightning, power outages, or other electrical disturbances. Surge protective devices, or SPDs, can help to protect sensitive electronic equipment from damage. Always consult the NEC for specific requirements and regulations regarding electrical wiring.